All right, let's jump right into this explainer. Today, we're going to learn how to build a highly accurate face and object detection system from absolute scratch using Python. We're totally demystifying computer vision to show you just how accessible it is to build these incredibly powerful tools right on your own local machine. You know, face detection is literally everywhere these days. As our source material points out, it unlocks our phones, acts as our passports, and yeah, it even allows drones to track people in crowds. And while the sheer ubiquity of this tech can definitely feel a bit intimidating, we're going to flip the script today. Instead of just being passive users, we are taking control by building this technology ourselves. So here is our roadmap for the explainer. We're covering the power of face detection, setting up our tools, processing static images, transitioning to live video, and finally optimizing with GPU power. Let's dive in. Section 1, the power of face detection. Look, this workflow isn't just about drawing fancy little boxes around faces. It gives you a seriously adaptable foundation. Because we're using Python and computer vision, you can teach your model to detect almost anything. Cars, specific people, whatever you want. Once you understand these core mechanics, you are basically looking at the building blocks for smart security systems, custom robotics, or even interactive games. The versatility is just endless. Moving on to Section 2, setting up our tools. Believe it or not, for this specific workflow, Windows is actually the better operating system for handling live camera feeds with OpenCV. So our setup looks kind of like this. We use Miniconda to manage our workspace, run Python 3.12, and install OpenCV, which is just a powerhouse computer vision library, along with another library called Ultralytics. And finally, we bring it all together inside JupyterLab. Now, we are writing every single line manually today because, let's be real, that is the absolute best way to learn. But hey, if you want to speed up your workflow later, the source material highlights a really great resource, HubSpot's free AI Coding Showdown. It's based on Matt Wolf's work, and it actually gives you copy and paste prompts to test OpenAI Codex against Claude Code. It's a super helpful way to compare their setup and speed side by side to find the perfect AI assistant for your own projects. All right, Section 3, processing static images. The AI model we're using here is so cool. It's called YOLO, which stands for You Only Look Once. It lives right inside that Ultralytics library we just installed. YOLO is pretty famous in the computer vision world because it somehow manages to be super accurate while remaining lightning fast, which is exactly what you need for real-time detection. We're going to start specifically with a lightweight version called YOLO V8 Nano. But the crazy thing here, right out of the box, this base YOLO Nano model is incredibly smart. Without you having to teach it a single thing, it automatically knows how to detect exactly 79 different classes of everyday objects. Seed it some demo photos and boom, the results are instant. It draws bounding boxes and spits out confidence scores right away. Like it might be 85% confident it sees a laptop or 76% confident there's a cup. It flawlessly identifies people, cars, cats, you name it. But there is one massive catch. And here is our first real plot twist. A human face? It's actually not included in those 79 default classes. The base model can totally tell you there's a person in the frame, but it just hasn't been trained to draw a box specifically around their face. So, to work around this without spending weeks training an AI from scratch, we turned to the open source community. A developer named Akanameov built a dedicated YOLO V8 medium face model that's just sitting there on GitHub. Our clever little Python solution is to run both models at the exact same time. We pass the image to the base model to find the cats and cups, and then pass that processed image right into the face model. The final result combines them perfectly. Which brings us to Section 4, transitioning to live video. To wrap your head around coding live video, don't think of a video feed as a continuous stream. Just think of it as a really, really fast-moving loop of static image frames. If you can process one static image, you can process a video. You just have to do it over and over again, incredibly quickly. So in our Python code, the logic is pretty straightforward. First, we use OpenCV's video capture to hook into our webcam. Then we open a continuous while loop. Inside that loop, we grab a single frame, pass it through both of our YOLO models, and display that processed frame on our screen for just 1 single millisecond using the wait key command. Then the loop instantly repeats. It happens so fast it creates the total illusion of live video, and it just keeps looping until we hit the X key to shut it down. Finally, Section 5, optimizing with GPU power.
Now, when you first run this new video loop, you're probably going to hit a wall. If you run both of these heavy AI models on just your computer's standard processor, the CPU, you'll immediately notice the video feed becomes painfully sluggish. It stutters, it drops frames, it lags completely. Running two complex AI models at once is just way too heavy a workload for a standard CPU.
To fix this, we've got to offload that heavy lifting to our graphics processing unit, the GPU, because it is literally purpose-built for this exact kind of math. First, we check our NVIDIA GPU's CUDA version in the terminal. Then we tailor a PyTorch installation command for Windows so the drivers talk to each other properly. And honestly, the code change itself is beautifully simple. We just take our model variables in Python and add a quick little string method, wrapping them to CUDA.
Guys, the difference is night and day. Shifting the processing from the CPU over to the GPU completely transforms the application. The lag totally disappears, giving you a buttery smooth feed. It operates in real time, instantly drawing tracking boxes around your face, your phone, and, as tested in the source material with a lovely feline assistant named Neil, it flawlessly tracks your pet cat as they move across the room.
So, now that you've peered under the hood, demystified computer vision, and understand exactly how to build a real-time face and object detector from absolute scratch, the power is totally in your hands. You've got a solid, adaptable foundation running beautifully on your GPU. The only question left is, what are you going to build with this real-time AI detector in your next project?